My presentation today is based on food analysis of the food samples that are collected over the semester, and this is my presentation. The chemicals involved are sulfonylamide SA and 1-naphthyl ethylene diamine dichloride dihydrochloride or NED, phosphoric acid, potassium nitrate, ammonium chloride, EDTA, activated charcoal, glacial acetic acid, zinc acetate dehydrate, potassium hexacyanophyric trihydrate, and NaOH. The equipment used include Ziploc bags, blender, measuring cylinder, balance spatula, pipette and pipette filler, centrifuge tube, conical flask, test tube and test tube racks, funnel, cuvette, and weigh bottles. Sample collection. Food sample were collected for 10 days and recorded in a 24-hour dietary record. Also, the food samples were collected from a 6 days meal in any day of the week. All the food samples were brought to the lab and stored in the deep refrigerator. Weighing of the food sample, unfortunately, my video here could not show. It should show me weighing of the food samples and the weight balance. The sample homogenization. This involves the homogenization or the digestion of the food samples according to the day that it's collected. These food samples were homogenized using a blender inside the lab. Heat food samples were homogenized using a food blender. Also, in this video, in this slide, a video should show, but unfortunately, it can't went through. And all the centrifugal tube was labeled. This is after homogenization. The reagents were added together with the water, or added into a conical flask, and then it was labeled. Labeling here is very important because we are working with in terms of nitrite and nitrate. We are working with 6 repetition of 6, since we have food samples from 60s, so we will be doing a run of 3 runs of 6 and to test for nitrite and nitrate in order to extract the an amount that is testable. Mixture was then transferred in the centrifuge tube and centrifuged to 3000 rpm and freezed, as shown in the diagram. The proper way of transferring water, transferring any liquid into the centrifugal tube. Nitrate and nitrate test. So after all that is done, the glass was collected and the sample was filtered. The filtrate was divided, and the buffer and color region was added for extraction of nitrate. Solution was then mixed. Solution was filled into sets of conical flask. Color region was added for nitrate to test for nitrate. Both the nitrate and nitrite was kept in the dark for 30 minutes. Sample placed in the cuvette, and absorbance was measured using UV spectrophotometer. So all the absorbance measured, there were recorded in the Excel form. This is just a picture showing how filtration was done into the control flask, the filtering of the solution. Vitamin C. This is the testing of how the testing of vitamin C was done. Nitrate was tested using UV spectrophotometer, while vitamin C samples was tested for vitamin C by the titration method. So here the burette was filled with interphenol solution to the 0 mark. 3 replicate setup was prepared. Ammonium chloride buffer was added to the 3 flask, and 2 ml ascorbic acid solution, which is ascorbic acid solution was added to each flask. It was titrated to the end point, and volume was recorded for the 3 trials. Data was recorded, and the percentage ascorbic acid in the sample was calculated. This is the confidence interval result for the 3 elements, vitamin C, nitrites, and nitrates. So as you can see, the confidence interval for vitamin C is 101,000 and 7.75 for nitrate. Nitrate it's 1179.67, and for nitrite it's 6.78. Also the mean for vitamin C is given here, standard deviation also for nitrate and nitrate and nitrate. And this is just to show the tedious calculation for data for the raw student 2 for 2 students, and this is for raw student 2. It shows the average to be 7.6, the standard deviation to be 2.8, and the that's for nitrate, and for nitrate the standard deviation is 28.9, and the average is 28.9, and the standard deviation is 18.7. For nitrate, the average is 7.6, and the standard deviation is 2.891. This table or this data will give us the information on how to draw the graph and how to plot the graph. It will also give us the equation of the graph that we want to draw. And this is the raw data for the vitamin C. It shows the volume, the concentration, and the average incident deviation. This is after the titration is done of the 3 repetitions. For student 1, showing here the same table as for student 2, but the calculation of the absorbance is also given, and that's where the graph come from. The data is the data given on these 2 tables will give us a indication of how we draw a graph, of the blue dots as shown on the table, on the graph, sorry. And this is the overall stats of the overall stats of the analysis of the data given. So in here you see the stats for nitrate. TDS calculation was 6.61, is 6.61. Nitrate is 34.026, vitamin C is 4.32. The total is 7.13 for nitrate, 31 for nitrate, and vitamin C is 2.8 mg/kg. That's per day. The pool standard deviation was also calculation, and this is the overall Stats for the standard deviation for nitrite, it's 3.08. For nitrate, it's 18.57. For vitamin C, 0.71. The average body weight was 80 kg. The EDI for EDI, that is in mg kg between the day 1 is 0.08 for nitrite, 0.39 for nitrate, and 0.035 for vitamin C, and the confidence interval at 0.05. For nitrate, it's 2.33. For nitrate, it's 11.66, and for vitamin C, it's 0.57. So that is the overall presentation that I have for the analysis, and hopefully it gives a bit indication how the overall analysis and test was done. Thank you.